All right, so here we go with 4.1 stoichiometry, and this is in our new unit, Unit 4, chemical quantities. We want to start by recapping the s'more activity that we did in class today. And if you'll notice on the top of the page here, I've got the chemical equation that we wrote for the creation of a s'more. So we've got 2S, and remember S stood for graham crackers, plus the which was the marshmallow. We only needed one of those, plus the 3 chocolate peaches, which is the chocolate pieces, which is the OR. And if you combine all those things together, you get a single s'more. So from this equation, we can determine the ratio of all the materials involved. So for instance, if if you've got one marshmallow, you can say, well, how many graham crackers am I going to need? Well, I'll need 2 because it's a 1-to-2 ratio. If you had 55 marshmallows, you could say, well, how many graham crackers will I need? Well, I mean, you need 110 graham crackers because you have to multiply that 2 because of the ratio. So what can we do with this info? Well, if we're given the mass of the chocolate, we could essentially figure out how many s'mores there were by knowing the ratio between chocolate pieces and s'mores, being 3 to 1. If we're given the number of s'mores required, well, we could figure out how many graham crackers that we would need. And then finally, we could figure out what mass of marshmallow would be required to use up all of the chocolate pieces we'd have in our household. So there's a lot that we can do with this single equation. Now, all these things on the bottom, although they kind of seem goofy, like why would you ever write a chemical equation for s'mores? I mean, we could figure that out. But the process of doing this isn't that goofy. If you had a huge party and you're trying to figure out how much material to go purchase so that everybody could have a single s'more, this is the process you would use. And this same process is what we're going to use in order to determine the amounts of chemicals that we either need to make something or how much product we can actually get from the materials that we actually have. So we're going to look at a quick example here to start us out. And we're going to look at a reaction between magnesium, which is a metal, and hydrochloric acid, or HCl, hydrogen chloride, as we'll call it right now. So the question is this. We want to determine the amount of hydrogen that can be formed from 2 grams of hydrogen chloride during the following reaction. So you can see our reactants, our magnesium. Magnesium is a metal. We're going to add that to the HCl, the hydrogen chloride, which is an acid. And that's going to yield hydrogen gas. Remember, hydrogen is one of the Hofbrinkels, so it's H2 plus magnesium chloride. All right? Now, there are a couple of steps that we're going to go through in order to solve this particular problem. Step number 1 is we want to balance the chemical equation. And as you can notice above, it's currently not balanced, and we'll get to that in a second. Step number 2 is to find the moles of the given. What was given? Well, we know that there's 2 grams of hydrogen chloride. That's our given. So we want to be able to go from grams of hydrogen chloride to moles, and we did that way back in Unit 2. Then we want to calculate the moles using ratios. So what I mean by that is we want to go from moles of hydrogen chloride to moles of hydrogen. That means we're going from the given to the unknown. And then once we know the moles of the unknown, we can then find the mass of the unknown using the unknown's molar mass, and then figure out its mass from there. All right, so let's actually do this. So again, like I said, we're going to start out with 2 grams of HCl. And step number 1 from the previous slide is we need to balance this guy. And all we need to do to balance it is to toss a 2 coefficient in front of the HCl, and we should be good to go. Let me clean that up a little bit. There we go. Okay, so we've got 2 grams. Now, step 2 was to take the mass of the given, which is this, and to turn that into moles. All right, let's see how we can do that. Let's see, 2 grams, so let's go 2.0 G, and I'm actually going to say HCl just to keep everything straight. Use my dimensional analysis from Unit 2. And in order to go from grams to moles, oh yeah, that's right, the molar mass. Remember, that's the mass of 1 mole of this particular substance. Well, hydrogen has a molar mass of about 1.01, and let's see, chlorine is about 35.45. So if we add those 2 up, we're going to get about 36.46 grams of HCl, 1 mole of HCl. All right, very cool. Now, if you'll notice, I've got grams on the bottom, and I've got grams on top. So I'm going to go ahead and use my red pen here to cross those out. Grams of HCl, grams of HCl. See, those go away. Now, if I would stop right here, I'd be left with moles of HCl. And you certainly can get your calculator out, and you can do 2 times 1 divided by 1 times 36.46, and you're going to get a very small number. However, I'm going to encourage that you learn how to do all of the processes in one single line. The fewer number of times that you actually have to pick up a calculator, the better. Things are going to go a little bit quicker, it'll be a little bit faster on tests, and the less mistakes you might make. What was the next step? Well, if this is step number 1, right there, step number 2 was to go ahead and convert from the moles of HCl to the moles of the unknown. So we have to use the mole ratio to do that. And where's the mole ratio come from? Well, it comes from the coefficients. The coefficient is easy to see in HCl. It's written. It's right there. We have 2 moles of HCl for every 1 mole of hydrogen gas. Remember, we like to talk in moles because atoms are so darn small, it's really infeasible to say, well, for every 2 molecules of HCl, we'll produce 1 molecule of hydrogen. That's a true statement, but we can't really utilize that. So let's talk in moles. For every 2 moles of HCl, we get 1 mole of hydrogen. That's a bit better. Okay, so that's our second step. And if you'll notice it once again, we get moles of HCl to cancel out. Now, if we would stop right here, again, we could pick up our calculator and we could do some calculations, and we would figure out moles of hydrogen gas. But the problem doesn't ask us to find moles of hydrogen gas, it asks us to find grams of hydrogen gas. Well, that leads me to my last step. And by the way, folks, I suppose to keep in context, this is step 2, step 3, and what I'll do here is step 4. Step number 1, remember, is balancing. I always want to balance first. So my step 4 is going to be to go from the moles of the unknown, which is H2 in this case, to the grams of the unknown. And that's going to entail me using the molar mass of the unknown. And in this case, it's 2.02. Remember that we've got H2, so we've got 2 hydrogens, add them up, and you get 2.02 grams per 1 mole. That's of hydrogen gas, of H2. All right, so the last time I take out my red pen, cross out my moles of H2, and then finally the last thing that I have here are grams of H2. Okay, grams of H2, and that's good. Now the purple box or blue box there isn't my final answer. I have to do the math with everything. And when I do that, and you can certainly correct or check my math if you'd like, but I believe my final answer in this case is going to come out to be, let's see, how about 0.055? So 0.055 grams of H2. There we go. So that's pretty cool. We were given a certain amount of hydrochloric acid, or HCl, and we asked, well, how much hydrogen gas could we actually produce? And at the end of the day, it's about 0.055 grams of hydrogen gas. It's a very important and very powerful tool, which we're going to use a lot as the semester rolls on. All right, so that's one example. Now, I'm going to throw 2 more examples up here. I'm going to have you pause the video after you read this and write this down, and I want you to go through the process. So go ahead and pause the video and write this down and try to figure out yourself. All right, so if you're back, here is the balanced chemical equation, and there is the correct math that you would need to do to figure out this particular problem. Go ahead and pause the video and write that down if you need, and make any edits to what you did, and we'll go on to the next problem. This one's a little bit trickier because the equation is a little bit harder to write, I believe. Go ahead and pause the video. And welcome back. Here's the balanced equation. Here is the final answer. And here is the work that was required to get to that final answer. All right, so that's stoichiometry. Lots of practice in class tomorrow, lab on Wednesday, Thursday, and Friday. So we got a lot of lab work this week, and then we'll just roll that right into next week. All right, that's 4.1.